Hello all, welcome back to the tutorial of C programming for beginners. Hi, this is Sakthi Arun, M.Tech student from NIT Patna. In my previous lecture video, so far I have given some of the examples of types of an operators based upon the role of operators. Okay, so in this lecture video, I'm going to explain you guys about the bitwise operators. Okay. So basically, the bitwise operators contains these following operators in as a bitwise operators. Okay, so the first one is an using this tilt operator. Okay, so this tilt operator basically it's an unary operator which work on a single operands. Okay, and this is like a shift operator where you shift your values with the bit. Either this is for left side and this is for right side. Okay, and this is for an AND operations and in a bitwise, and this is an XOR operations, and this is an OR operations. Okay, so the truth table of an XOR operation is new for you all. So basically for OR operator, for XOR operators, if the operands are in the same type like a true and true or false and false, then you get the result as 0. Okay, which means if it's 0 0 or if it is 1 1. Okay, so for this both case you will get the value as 0. Okay, so this is what the result of an XOR operations. Okay, or if any one of the output is differs with any one of the previous operand, say like one is 0 and another is 1, or one is the A is equal to, suppose you say this is A and this is a B. Okay, so if A is 1 and this is 0. Okay, so in this case two values differing each other, so in this case we will get the output as 1. Okay, so this is what an truth table for XOR gate. Okay, so with this understanding, let me move to some of the examples. Okay, so basically this bitwise operation is done on an in an individual operator bitwise. Okay, so for that the basic AND and OR truth tables I have explained in the in the previous lecture video. Okay, so whomever missed the theoretical explanations, just go back to my two videos previous lecture, so that you will get to understand better about the truth tables of and or operators. Okay, so okay, let me take the first example. It's 2 and 3. Okay, so 2, basically we can write the 2 as 0 1 0. Okay, so for 3 we can write it is in a binary manner. We can write it's a 0 1 1. Okay, so when you are doing AND operations, in AND the both inputs of an operand should be in 1. If any one of the operand value has a 0, then the result will be 0. Okay, so if you compare with 0 and 1 here, then it is 0. If it is a 1 and 1, so both are 1, so it is 1. If both are 0, I already told, if any one of the input is 0, then it's 0, but here both are 0, so the result is also 0. Okay, so this is again if you convert this binary value into decimal, then you will get the value as 2. Okay, so that's what we got the result as 2. So now let me move to the next example for OR operations. Okay, so for OR operations we have to do for 2 and 3 here. So for 2 it's 0 1 0 0, and for 3 it is 0 1 1. Okay, so for OR operators, if any one of the input has a 1, then the output is also 1. Okay, so if you compare here, it's 1 and this is also 1 and this is 0. Why? Because in this input has a 1 and here both inputs are 1, so no problem. If either one of the input is 1, then we can store it as a 1. Okay, so here both are 0, so we have given here as a 0. So this is if you convert this value to a decimal, then you will get as a 3. Okay, so that's what we got here as a result. Okay, so the next thing is it's a not operator. Okay, for not operators we first take an ones complement. Okay, then based upon the notations or symbols in the most bit, then you try to write the values of the values in the twos complement. Okay, so for that let me take an example as say I take an example as 7. Okay, so for 7 we can say it's 1 1 1. Okay, so for this now or if I take any examples Okay, this it's fine. I'll take this as example. Okay, so this is the value of 7. Now what you have to do is you have to write the complement value. It's 1 0 0 0. Okay, and whatever the value is previous here, it's all like a 1 1 1. Okay, so the negative sign basically represents the minus here, and whatever is available you write it is as same as the values. Okay, so this is what it's a value for an 8. Okay, because it's a 1, it's 2, it's 4, and this is 8. Okay, so the value is 8. So now for not up, if I do a not for 7, then the value is minus 8. Okay, so this is what an basic example for a not. The next thing is it's a shift bit. Okay, for shift we have to find how many bits we are shifting. Okay, so let me take the example here. It's in shift we have both things. We have left shift and right shift. Okay, so what is this point? I'll come back with the example here. So let's first explain with the example. It's 4 4, it's left shift with the 1. Okay, so what does the for an if you convert this 4 to a binary value, so it is 0 1 0 0. Okay, so this is a 4 value. If I convert if I try to shift one bit to the left side, okay, now the value become 1 0 0. Okay, so if I convert this to this is a binary value, so if I convert to a decimal, then I get value as 8. Okay, so this is what a left shift is doing. If you see here, I give an input as a 4. Okay, but as an output I got as a 8. Okay, so for a left shift what happened is 4 becomes 8, which is a multiple of 2. So that's why it is mentioned here the equivalent value will be multiplication by 2. Okay, so for a left shift, the left shift actually our value is promoted from 4 to 8, whereas in case of a right shift, let us find here what happened. This is an example of right shift. The same 4 which is 1 bit shifted to right side. So if I convert this 4 to binary value, it's 0 1 0 0. Okay, so now what I'm trying to do, I'm going to shift the value one shift to the right side. Okay, sorry, this shift I am going. Okay, let me redraw again such that you will get a better understanding. What happened here is a 4 which is shifted right side as a 1 bit. Okay, so for the decimal value it's 4. If I convert to binary, then the value is 0 1 0 0. Okay, so now what we have to do, we have to shift the value to one side, so it's 0 0 1 0. Okay, so now this is a binary value. If I convert this binary to decimal, then I get a value as a 2. Okay, so this is our result. What actually happened is I given 4 as an input, but I got output as a 2. So what happened is 4 divided by 2 is equal to 2. Okay, so our value is actually divided by 2. So that's what mentioned here. Okay, so this by right shift, basically our value is got demoted. Okay, I mean it got reduced. So the final thing is an XOR operators. In XOR operators, I already mentioned, if both inputs are same value, then it results in a 0 output. If any one of them differs with the other, then the result is 1. Okay, so here it's 2 XOR 5. So in this case what happens is, let me convert 2 to binary. It's 0 1 0, and for 5 it is 1 0 1. Okay, so here these both inputs actually differs. So it's 1, again it's differs, it's 1, and again this is also differs. Okay, so this if I convert this binary value to decimal, then I get the value as 7. Okay, so this is what we got as a result here. Okay, so for all the operators in the Bitwise operators, I have given basic examples with the theoretical concepts. Okay, so in our next lecture video, I will simulate with the simple C programs with all these operators. Okay, so that you will get a better understanding. If you guys have any doubt or comments, please post it in the comment section. Okay, thank you all for watching this video.